students, myself Dr. Pallavi Rai and I am going to teach you BP 405T pharmacognosy subject, and today we will be continuing with our topic further on plant tissue culture. So, we will be discussing about the growth and maintenance of plant tissue culture in this lecture. Before we move further on how we study the growth as well as maintain the cultures, we have to understand the basic steps involved in a plant tissue culture. Though we have gone through it earlier, but not in a proper stepwise pattern. So, we are going to discuss that initially. So, first of all, while doing any plant tissue culture, you have to first of all prepare a suitable nutrient medium. For preparing a suitable nutrient medium, you should be clear that what is the aim of your plant tissue culture. Which type of production do you want? You want more yield of which type, either in the terms of secondary metabolite or in the terms of more weight of that particular plant part. Depending upon that, you will choose the type of nutrient culture which will suit. For that, there are two techniques by which you can prepare your nutrient culture. First of all, you have to take all the different salts which we have discussed in the last classes, that there are different types of nutrient mediums. So, we will choose all the different salts separately, we will weigh them. After weighing them, we will mainly dilute them to a particular concentration, like if it is 5 millimole per liter. So, we will make that concentration of the solution. So, in this way we will prepare A to Z all the different types of the solutions of separate salts, including sugars, nitrogen source, phosphorus source, potassium source, etc. And afterwards, in the predetermined ratio, we are going to mix the already prepared solutions. So, that is one technique. The second technique is that we weigh all the salts in one particular medium, in one particular flask, and after that, depending upon the last volume, for example, we have to prepare 1 liter of the nutrient medium. So, according to that 1 liter requirement, we will weigh all the different salts, glucose, nitrogen sources. If we are adding any natural substances like yeast extracts or coconut milk, we will add all those in that 1 liter flask itself, and later on we will make up the volume. So, it can be done in both the patterns, that you prepare the solutions individually and then mix them, or you weigh all the ingredients together and mix them and make up the volume. So, you will prepare your nutrient medium, that is the first step. Now, after preparation of the nutrient medium, you have to be very clear that depending upon the type of plant tissue culture, whether you are going for a callus culture which requires a solid medium, or you require a suspension culture which is a liquid medium, you have to select the solidifying agent. So, generally we use agar as the solidifying agent. So, we will be adding the agar also in this particular medium, and after that we will autoclave it. So, for autoclaving, you will use the general autoclave which is used in any kind of microbiological technique. And after autoclaving, when the nutrient medium becomes completely sterile in nature, we will pour them in the required mediums. If it is a petri dish, we will pour it in a petri dish. If it is a type of a tube culture, slant tube culture, we will replace the medium in that tube culture. So, now our nutrient medium is ready for the further study. The second step is selection of the explant. So, we have studied the different types of culture. We know that depending upon which type of culture, if it is root tip, shoot tip, flower culture, we select the plant part. On the same behalf, we are going to select either the bud, leaf, root, whichever part we are considering to be the best suitable for growing our plant tissue culture. After that, the next step would be that we have to sterilize our explant. For sterilizing, what do we use? We will use sodium hypochlorite, mercuric hypochlorite can be used, or mercuric chloride solution can be used, and after treating them with that, we can also further treat it with 60 to 70% of ethanol, or after treating with ethanol, the next step is that we have to again wash it aseptically with sterile water for 6 to 10 times. We have to make it completely free of the sterilizing agent as well. So, this technique is done completely in aseptic area where no microbial growth is possible. Now, we have the nutrient medium and the explant, both are ready, both are sterile. So, in the aseptic area only we will be transferring our explant into this sterile medium, and after that the next step comes, that is incubation. So, our culture will now be incubated at 25 plus minus 2 degree centigrade, and the relative humidity is around 50 to 70% for about 16 hours of photo period. So, photo period means what? 16 hours of sunlight, 8 hours of darkness. So, this cycle will go on, and generally within a period of 7 days we will find that the callus development takes place. So, once the callus development takes place, now comes the next step, that is regeneration. So, what happens that the callus is a undifferentiated mass of cells which is formed initially in the first 7 days. After that we will take some part of the callus and transfer it into another medium, fresh medium, which will be suitable for growth of the roots or the shoots or entire plant. And once we incubate them in that, then we will see that the plantlets, they start regenerating inside that particular medium. So, now these plants will be regenerated mainly when we transfer the portion of the callus in another medium and we induce either the root or the shoot formation from the explants. Now, once these regeneration is done, after that we will let the plantlets harden, we will let it become more stronger by, we will gradually start exposing the plantlets for acclimatization to the environmental conditions. So, now they were in a lab in a protected manner. So, now we will gradually start increasing its exposure in the external environment, external sunlight, external water, which is not sterilized, so that gradually they adapt to the external environment and become as good as a plant in nature. So, once it has acclimatized, we transfer the plantlets into the greenhouse, and from the greenhouse it is transferred into the field conditions. So, these are the different steps involved in plant tissue culture. Now, we come further to the main topic, that is the growth and maintenance. So, basically for the growth and maintenance of this plant tissue culture, there are mainly 3 types of culture system which are generally followed. We have studied them, again we will be discussing that we will either use the callus masses, which is generally on a solidified medium, and this is also known as the static culture. The second one is in liquid medium, which is known as the suspension culture, and the peculiarity of suspension culture is that it does not consist of a lump of cell, but it consists of single cells or some cell aggregates which are present due to agitation of the suspension culture. The third one is the protoplast culture, and in protoplast culture what is done is that the cell membrane is there intact inside the cell, but the cell wall is missing. We have removed the cell wall completely. So, what is remaining is a cell without the cell wall, which is the protoplast. Protoplast can be cultured either in a callus form or in a suspension form. However, protoplast is considered to be one of the best techniques for doing plant tissue culture, because it becomes very easy to do any kind of changes in the plant properties. Now, we come to the maintenance. So, what happens is that when we are doing plant tissue culture, we have taken the plant cells, we have put it in a medium, and gradually with time what will be happening? All the nutrients is getting taken up by the plant cells. That is a natural phenomena. It is going on feeding on the nutrients. But there a time comes when the nutrients is completely finished. It is completely over. It is not there. So, what will the plant cell do? They will start dying in the lack of the nutrients. So, basically what happens with time? That depletion of nutrients takes place. Also, there will be gradual loss of water. Our medium is having a lot of water, and with time what will happen? The water is going to either be used up by the cells or be lost in the atmosphere. due to evaporation. So, there will be a gradual loss of water also. And thirdly, because the cells are doing many of its metabolic reactions. So, there is lot of anabolism going on, catabolism going on, which lead to the release of the toxic materials, and this leads to the accumulation of metabolic toxins. So, these are the three reasons because of which we cannot leave a culture as it is for long period of time. A proper culture sustain itself for maximum 28 days or 4 weeks. After that, we need to replenish the culture medium, or we have to shift the callus into a fresh medium so that the callus continues to sustain its viability. It is alive for a longer period of time. So, in order to do that, what is the next step? We have to do the subculture of the callus into a fresh medium. So, healthy callus tissue of sufficient size, about 5 to 10 mm in diameter, is taken, and its weight is about 20 to 100 milligram. This is transferred under aseptic condition into a fresh medium. The subculturing, this process needs to be repeated every 4 to 5 weeks. Many callus cells, however, remain healthy and continue to grow at a slow rate for much longer period without subculturing if the incubation is carried out at a lower temperature. So, if we reduce the temperature about 5 to 10 degrees below the normal temperature, say about 16 to 18 degrees centigrade, because some plants do grow in that temperature, like in the hilly regions, in mountainous regions, generally the temperature is very low. So, if there are few plants which can be grown at that temperature, in that case the time for the first, you can say the tenure for a culture to last is much longer compared to the normal conditions, that is 4 weeks. So, we have to see that what is the requirement of temperature for our plant. If it is lesser, we can do the subculturing at a longer interval of time. However, the normal depletion, as I told, takes place at about 28 days. So, callus, when it develops, there are different appearances of callus. It is very difficult for a researcher to know that what this callus is depicting. So, we have to have a clear idea that what kind of callus this is. So, if the callus is showing different colors, for example, it is showing white, it means that this callus was grown in dark because it is not having any chlorophyll. The green color in callus is due to chlorophyll. It is not present means the callus was kept in dark environment, due to which the cell did not feel the need to synthesize the chlorophyll. If it is green in color, then obviously it is grown in a proper photo period, means 16 to 8 hours photo period was there. If it is yellow, yellow color develops because of the different carotenoid pigments which are present in a great amount in the plants. So, carotenoids give a yellow color to the plants. For example, certain xanthophylls are there along with chlorophylls, which give a yellow color to the leaves. So, this yellow color shows the presence of carotenoids. Purple color shows the presence of anthocyanins in the vacuoles. There are vacuoles, they are type of organelle in the plants. So, if the anthocyanins are present, they are showing the purple color. Brown color shows that there is a lot of excretion of phenolic substance or the formation of quinones. So, as you know that tannins are generally brownish in color, phenolic substances are generally brownish in color. So, if the callus is showing a brown color, means it is rich in the phenolic substances or in the quinones. So, callus culture may vary widely in texture, appearance and rate of growth. Some callus growth is heavily lignified and hard in texture, while others are very fragile. So, it depends that what is the source, what is the medium, what is our aim of the study. Depending upon that, the callus also changes its properties. The cells in the callus tissue vary in shape from spherical to elongated. So, they can be either spherical in shape or they can be elongated in shape. Now, here is just a case study of a suspension culture, that how the growth pattern is there in any kind of a culture. Okay. So, here if we are doing a culture and it is a suspension culture, what happens is that initial phase, here we can see that we have plotted a graph of time versus cell number. We have counted the number of cells in a particular medium, and it is seen that initially when we start the culture, there is a very gradual increase in the number of the cells, which is known as the lag phase. After some time, the cells, they have a slight increase in the rate of division, cell division, and that phase is, this increased phase is known as the log phase. Once the log phase has achieved, there is a sudden or steep rise in the number of the cells, and this is known as the linear phase. So, linear phase is the phase where you have the mass production of the cells in a very short period of time. Now, all the cells have taken up majority of the nutrients, and because the nutrients are getting depleted now, after that what happens, that there is a slowdown in the cell division, which is known as the deceleration phase, where you can say this there is a slowing of speed of cell division, and later once the nutrients are completely used up, the cells enter into a steady state or a stationary phase. So, this S-shaped curve is formed in any kind of culture. So, here we have taken the example of a suspension culture, where the cell is, first of all, there is some cells are taken and they are transferred into a liquid nutrient medium in a flask, and they are continuously agitating during the culture period. Due to the agitation, what happens, that the liquid medium is getting aerated and simultaneously the cells are getting dispersed in the medium. The composition of the medium for establishment of the suspension culture could be the same as for that of the callus culture, except here we are not adding the agar, which is the solidifying agent. Now, once we have transferred the cells into a suitable liquid medium, they divide after a lag phase, and then the linearity increases the population of the cells. The soft callus generally forms a suspension culture without much difficulty. The release of the cells and tissue fragments from the less fiable cell masses, callus masses, and the maintenance of good degree of cell separation may often be promoted by presence of the liquid medium of high auxin concentration. So, it has been observed that if we maintain a high auxin concentration in our suspension culture, then we can maintain the good degree of cell separation, as well as the cell remains, you can say, more active at for a longer period of time if we are adding more and more auxin to the particular medium. Even if we have a balance between the yeast extract along with auxins and kinetin, it also has been found to be very helpful in good suspension culture. So, once we are doing all these cultures, everything is going on, a lot of documentation comes in inside a particular plant tissue culture lab. So, we have to keep on measuring, observing our callus culture, suspension culture, or whichever culture we are performing, and depending upon the nutrient levels and the rate of the cell division, we can understand that when will be the stationary phase which is coming. So, to predetermine that what will be the time when the stationary phase enters, researchers do different types of measurements. They will first of all take the initial cell density of the suspension culture, so that they understand that what is the initial cell density, we have given the nutrients, we know the temperature condition. So, what will be the rate at which the cells will utilize the nutrients, and what will be the time when the stationary phase will appear. So, they know this particular thing. Then duration of the lag phase. What will be the time when the cell division will not be initiated completely? It will take time for the cells to start dividing at a faster rate. So, we should know that what will be the time, how much time it will take, that from the initial cell number stage to a higher cell number stage is reached. And then we should also know that what the kind of cells we are culturing, what is the type of that cell and what is the growth rate of that cell. So, we can predetermine that when will it reach the linearity stage and when it will reach the deceleration stage and then the stationary stage. So, we need to understand all these aspects when we are doing the plant tissue culture, and we understand that how can we maintain the growth of the callus culture without any loss in any of our studies. So, we have studied in the last lectures in the types of culture regarding subculturing when we were discussing about suspension culture. So, I will be just revising this topic because this part is it also comes under the maintenance. So, when we are maintaining our culture, we do the subculturing, and for subculturing, what are the different ways in which the subculturing can be done? First is the batch culture, then is the semi-continuous culture, and then we have the continuous culture. Continuous culture is of two types, open culture and closed culture, and further open culture is of two types, that is turbidostatic and chemostatic. So, in batch culture what happens? In batch culture normally we do the whole plant tissue culture in one step. Now, once the one step is over, we will take few cells and then we will put it into the next medium. Okay. So, every time we are going to replace the cells into a new medium, every time there will be a fresh medium or a fresh batch. So, this type of culture is known as a batch culture, where you took few cells, you put it in a culture, after 4 weeks that culture is completely depleted, you took those cells again and transferred it into a fresh medium. So, completely entire process is getting repeated every 4 weeks. That is the batch culture. In semi-continuous culture, what is happening? That you have a culture and at a predetermined rate, you just decide randomly that at a speed of 2 ml per minute, you are going to enter a fresh medium inside the particular used up medium. For example, you are doing the subculturing and about say 28 days have been completed. Okay. Now, this is the time where the medium is completely lost its nutrition. At this point of time, you will enter fresh medium and you will remove the used up medium. So, this is possible generally in suspension cultures or liquid medium cultures, where you can continuously, what you can do is after 28 hours, rather than replacing the cells into a fresh medium, the cells are there only, but the medium is getting replaced. You have entered fresh medium inside the whole culture and the used up medium has been removed from the medium. So, this is semi-continuous culture. Now, what is continuous culture? In continuous culture, what happens? That at a predetermined rate, you have chosen that at 1 ml per minute, my fresh medium will enter the tank or this is the culture which is there. The medium is present inside, and at a fixed rate you are entering the particular fresh culture inside, and again at a fixed rate the used up medium is getting removed. So, this is a continuous process. There is an inlet and a outlet, and you have a predetermined rate at which this is going on. Okay. Now, further it is of two type, as I already told you. First, we will discuss about the closed system. In closed system, we always fix it randomly, that it can be either 1 ml per minute or 2 ml per minute, like that, and this process goes on again and again. But in the open culture, what happens? That we regulate it. We understand the consistency or the ingredients present inside the culture, and after that we regulate the flow, that yes, it should be increased, it should be decreased, whatever. Okay. So, for that if we measure the turbidity of the cells, the number of the cells will increase the turbidity. If we measure the turbidity, it is known as turbidistatic method. If we measure the chemical constituent, like if we measure the glucose content, then it is a chemostatic method. So, we can use either of the two, and based on that what amount of the cells are there or the chemicals are getting depleted, we will regulate the inlet of the fresh medium and exit of the used up medium. So, this is a closed open culture or a open continuous culture. So, with this we end the growth and maintenance part, and in the coming lecture we will be discussing about the applications of plant tissue culture. Thank you.